Hello, everyone. A very warm good evening to all of you, and welcome to Unacademy. Welcome to another important session for your climatology in the NCERT series that we have been running. This session deals with the concept of an air mass and also what happens when you have various different air masses. How do we get the naming of the air masses? What is a cyclonic circulation? The basics of a cyclonic circulation, and also, where do we have the largest of the cyclonic circulations across the planet? With the help of satellite image, we will take a look at that also. But we will also try to understand the generic circulation pattern, the type of formations thereby. So that is going to be our overall coverage in this particular session. If you are liking this initiative of ours, if you have benefited from that, please don't forget to share it with your friends, click on the like button, and subscribe to the channel if you have already not done so. Now, this is a portion which basically is chapter 9 of your NCRT. That is basically the case of that is what we had discussed. Now, this is in the same chapter, that is atmospheric circulation and weather systems. In the later portion, you have the case of this cyclonic circulation and air masses. So, in this chapter, we have already managed to discuss the case of the pressure systems, how the pressure gets created, dynamic pressure, thermal pressure, the case of when we talk about even the wind pattern, the factors influencing the wind movement, permanent wind systems, the local wind systems, the pressure belts, and now air masses and cyclones. And tropical cyclones is something that we are going to have a detailed discussion about tomorrow in a singular and separate video. This is to tell you that how a single concise chapter of NCRT of 11 pages, oftentimes you think that you have read it, but that is where the devil lies in the detail. Each and every sentence can hold a very large concept. That is what we are going to explore, and I will show it to you how almost the entire discussion of today's session will be restricted to 1.5 pages of NCRT itself. Now, before we proceed ahead with the discussion, announcement for all of you. Now, the Plus batch is available where you have the new batch which starts from the 1st of August. You can avail that session, get the practice answer writing, PYQ discussion, the test series, and be a part of the journey to clear the civil services examination with the best faculty in the country when it comes to English medium. And use the code IS English to avail the maximum possible discount. Now, we come to the case of air masses. Now, if you take a look at this term, air mass, okay, let's not overcomplicate it. Let us go by the direct implication and meaning of it. What is the immediate meaning of this that can be extracted? Air mass, mass of air, isn't it? That is a mass of air. Now, you are sitting in a room right now. That room will have the air around that. Many of the times, you would also have experienced that when you step out of your room, it is cooler or it is warmer. So your room temperature is not always the same as the outside temperature. That means what? That the air parcel in your room has gained a different temperature, different moisture characteristic as compared to the entire surrounding of your city. Many of the times within your city itself. You move from a forested region to an urbanized locality, you will observe that the temperature increases. You would have observed that in some parts of your city it is rainfall which is being experienced, in some parts no rain, dry condition. So is that a mass of air? After all, that is also air, that also has got mass. So when we consider the term air mass, what is the exact mass that we are referring to? So these are basically very large parcels of air, very large parcels of air. Okay, when I say very large air parcel, it can be hundreds and even 1,000 kilometer and more in terms of its dimension. It can span across very large continental area. Okay, so it can be hundreds of kilometer, hundreds or thousands of kilometers, right? Now, very large air parcel. Any large air parcel, do we consider it as an air mass? No. Every air parcel will have its unique property of temperature, moisture, pressure, etc. So when we have a very large air parcel having homogeneous, having homogeneous temperature and pressure or moisture conditions, moisture conditions and pressure. That is what you consider as an air mass. Okay. So when you talk about the case of this air mass, it is going to have a very large dimension, very large dimension. Okay. But either it will be warm or it will be cold, either it will be dry or it will be moist. It can vary. It will always vary. For example, when you go to, let's suppose, a Ladakh, you will experience cold temperatures, air will be cold. When you go to Rajasthan, Thar Desert, you will experience warmer conditions. When you go, let's suppose, over Bay of Bengal or Andaman Nicobar, you will experience very high amount of humidity, isn't it? So that is basically where you will always experience that the moisture conditions or the property of air tends to change. Himani, my dear, the Elevate batch, it is not Elevated batch, it is Elevate batch. Elevate batch, Indian geography has been done, physical geography is left, which will be done in the following month. But having said that, what I would recommend to you is get your basics correct with the NCRT of this series, and then you can always join the Elevate batch for the fundamentals of physical geography, and then you will be able to understand it easily, and you will go be able to go into the depth also. So get yourself well versed with this NCRT first, and then in the plus course we will take it a notch higher, so then you will not face any difficulty, you will not face the teething problem. Okay, Himani? Now, where does the air gain its property from? This temperature, moisture, etc., that we are talking about, where does the air gain this property from? It gains this property from the surface that it is in contact with. That surface which provides the conditions to the air, that surface is known as the source region. Source region. Okay. So let me compile it first of all before proceeding ahead. What is an air mass? A large mass of air which can span for hundreds or thousands of kilometers, having uniform property of temperature, moisture, humidity, and pressure. That is the case of the air mass. Homogeneous means uniform. Uniform. Okay. That is your air mass. Now, why will the air have different conditions? That is basically, suppose you take these examples. If let's suppose you are standing here, the air naturally will be warm, isn't it? It will be warm, it will be dry, moisture level will be very low. If you are here, whatever might be the temperature, but you know that moisture level will be very high because it is above an ocean. If you are here, you will know that air will be very cold. So it is the surface which is providing its property to the air in contact. That is the surface which is also referred to as the source region. So a source region is the area over which air masses originate or form. Okay, whose nature and properties largely determine the temperature and moisture characteristic of the air mass. Okay. So, how does the process take place? First of all, you consider a very large area. Now, if the air remains over a large area for a longer period of time, let's suppose a Sahara Desert, right? Sahara Desert is a very large desert, the largest desert of the world. Now, that Sahara Desert, if the air stays there for a long period of time, it will gain that desert like property. Hot conditions, dry conditions, air will gain that, right? Or Siberia in Russia, very cold conditions. Greenland, very cold conditions, very large area. If air stays there for a very long period of time, it will become very cold. So, first of all, air has to stay over the source region for sufficient period of time. Then, air picks up the characteristic of the underlying surface. A large body of air with uniform temperature and moisture is created, and then eventually that air can be transported from one region to another with the help of the prevailing winds. With the help of these prevailing winds. Okay. So that is the case of these particular air masses. Okay. And the source region. Now, these air masses are named differently: continental, polar, maritime, etc. So, how is it that we arrive at the naming of the air mass? Over a period of time, definitely air mass can change its property. If it is exposed to a different source region, for example, let's suppose air from Sahara goes into the Mediterranean Sea and lies over there for a long period of time, it becomes a kind of a moist air mass. So it can change its property provided it is exposed to that condition for a longer time, longer duration. Now, first thing, when you name the air mass, this is very vital for your overall understanding, the naming, the nomenclature of the air mass. Because many of us, we are unable to understand this factor of geography. And that is where you have the conclusion from the candidates. Geography is very technical, this and that. So understand this. First of all, air will have two major properties. One is the property of temperature, another is the property of moisture. Okay. Air can be hot or cold, or air can be dry or humid. Fair enough. Now, let's first tackle the case of the moisture content. Now, if an air, look at the background image, air masses can move with the help of the prevailing winds, the permanent winds, they can carry the air masses from one region to another. Take a look at this background image. I give you two parcels of air. One is in this particular place, A, in the region around Mongolia. Another is in this portion, B. If I ask you, out of A and B, which will have greater amount of moisture or higher humidity? Which will have higher amount of humidity, A or B? Always, it will be the case of B, isn't it? Why? Because B lies over the water body, A lies over the continental area, isn't it? So, based on the moisture presence, I can have simple classification of an air mass. So, that can be air masses can be classified as continental and it can be classified as maritime. Continental meaning dry air, maritime meaning moist air. So, any air mass which is dry, you have a prefix of a small c which is attached to the name of the air mass. Any air mass which is moist, you have a prefix of m which is attached to that air mass. That is how air masses can be named. This is the first part, the prefix. Then comes the role of temperature. Now, if even I ask a layman, a general person who has not studied geography, if I ask that person, where will it be colder, India or Antarctica? Everybody can come to a conclusion: Antarctica will be colder, India will be warmer. So, based upon the latitude, also, that means temperature changes. So based upon the temperature condition, you have the classification of air masses, and here suffix is added. So for an air mass at the region of equator, you add the suffix E. For the tropics, you add the suffix T. For the polar region, what is the polar region here referring to? Continents and oceans in the latitude 50° to 60° north and south. That is where you attach the suffix P. Then for the region of Arctic, Arctic is an ocean, by the way. Arctic is not a continent. Okay. So for the air mass which is associated with Arctic, very cold, but some amount of property of water body nearby. So that will be Arctic A, Arctic Ocean and the surrounding land. For Antarctica, double A. Okay. Antarctica is a large continent. It will be dry air. So Antarctica, double A. So for example, if I consider the region of equator, now at the region of equator, again take a look at the background map if you want. If I consider this region, what will be the moisture level? Moisture level will be high or low? Moisture level will be high. It is at the region of ocean. So when moisture level is high, what do we attach? We attach the term M. And it is present in equator. So we attach the term ME. This is the name of the air mass. For example, if let's suppose I consider this region, Delhi NCR, Lucknow, portion of UP, etc. Air will be dry or moist in this particular case. Air will be very dry. It is not closer to the water body. So air is dry. I will attach the term C. Now it is in the region of the area of what? Tropics. Tropic of Cancer passes through that region. So I will have the term T. So CT is the name of the air mass. Why poles and Arctic are considered different? Poles, my dear, is 90° north and 90° south. North pole is a point. South pole is a point. Okay. Around that entire South Pole is a very large continent which at one point of time was abundant with life. That is Antarctica. So Antarctica is a large continent on which South Pole lies. Around the region of North Pole, you have a frozen water body, frozen ocean. That is your Arctic Ocean. So that is the region of Arctic. Okay. So North Pole lies in the Arctic Ocean. Okay. I hope that is clear. So that is where you will basically observe, look at this map and understand the naming of the air masses. Maritime equatorial, maritime equatorial, maritime equatorial. All these are maritime equatorial. Okay. Now, here, Himani, your question itself has the answer. Your question is, why do maritime and continental tropical air masses have different weather effects despite both being tropical? Because one is maritime and one is continental. Maritime means moist, it will bring rainfall. Continental is dry, it will bring dry conditions. So weather conditions will be different. Please understand, air masses have two properties, one of temperature, one of moisture level. Okay, so both of them have to be targeted and understood. Then look at the tropical region. You have maritime tropical here, maritime tropical here, maritime tropical, continental tropical, here also continental tropical, continental tropical. Then, other than that, 50° to 60° latitude, polar, isn't it? Maritime polar, maritime polar, maritime polar, maritime polar, right? Continental polar plus continental Arctic, continental polar plus continental Arctic, continental Arctic, and here continental Antarctic, CAA. Like that, the air masses are named differently. Okay. I hope now the naming is sorted, that how the naming is done. Okay. I will revisit this image after some time when I will try to explain one of the satellite images of today. Okay. Today's 5 hours ago, a satellite image has indicated the formation of a cyclone in the region of northern Atlantic. So when I revisit or talk about that satellite image, I will revisit this map. But I want you to understand this map very carefully, how the naming is done. Yes, Satyam. Polar is 50° to 60° latitude. That is polar. Okay. So continental polar, for example, interior of Canada, cold and dry. Maritime polar, North Atlantic Ocean, cool but moist. Continental Arctic, the region of Greenland, very cold, dry. Continental Antarctic, much colder, more drier. Maritime tropical, Bay of Bengal, for example, warm, moist. Continental tropical, Sahara Desert, warm, dry. Okay. So this is how the source regions provide a kind of a feature to the air masses as well. This is a compilation for you that you can basically use for your revision. Continental polar, cold dry, in which region it will be 50 to around 60, 70, right? At that point of time, maritime polar, continental Arctic, then tropical can be of two types, right? This is what you can use for your revision as well. Okay. This is your whatever we have covered, NCRT has provided it in this much of the paragraph. That is why, even though I always say NCRT is the best book for your preparation, but for students, it can be unfairly harsh. For a student to be able to understand the intricacies of source region, the nomenclature, everything, it becomes very difficult if you are directly being talked about CP, CT, ME, MT, you will not be able to understand. But I hope now you are able to understand this in great detail. Okay. Now, if you take a look at all these air masses, okay, let's take a look at all these air masses. Now, if I draw this line here and I draw this line here, what do these lines indicate? These lines indicate the separation of warm air from cold air which is very warm in the tropics to air which is cold, that is maritime polar and so on. It might be isotherm, it might not be an isotherm. But nonetheless, it is separating air masses of different properties. Now, air masses of different properties, when they come head to head, will they mix with each other, become the best friends, and live happily ever after? No. They will have very unique properties because these are the air masses spreading up across thousands of kilometers. You cannot expect them to have the exact intermingling out there. So, whenever air masses of different properties, whenever they come head to head, they don't mix with each other. In fact, they will always form a kind of a zone of transition. They will form a zone of transition where warm air will have a greater volume, much more expansive. Cold air is heavier, a bit compressed. Now, if you are an individual standing here, you will experience higher temperature, you will experience a kind of warmer conditions, low pressure. Okay. Whereas if you are an individual who moves from here and comes here, colder conditions, suddenly the temperature reduces. So when you talk about this entirety of the region, what is this? This is what is known as a zone of transition. Now, this zone of transition is referred to as a front. Front. It is like a boundary area. Observe this animation: warm air, cold air. This is your zone of transition, where the temperature will change, the moisture content will change, etc. That is the zone of transition, which is referred to as a front. Formation of a front is the process which is referred to as frontogenesis. Frontogenesis, genesis means birth. So it is referred to as frontogenesis, that is birth of a front. Okay. So when a front gets created, that is frontogenesis. Now, again, I take you back to this map. From this map, can you all come to this conclusion that frontogenesis will be common in this area where the warm and the cold air masses will meet? It will be common in this area, isn't it? No, Veera, there is no continental equatorial air mass which exists. The reason being that around the region of equator, you receive daily rainfall because of the process of convection. During the day, the sun will heat it up so extensively, moisture will evaporate, you will have formation of clouds and everyday occurrence of rainfall. So around the region of equator, always moisture content is very high, right? Barring few regions like the this region of Kenya, etc. Every part of the planet will have moist conditions at equator. Because the conditions are always moist, you automatically attach the prefix M, and hence you do not find any continental equatorial air mass. Okay. Now, this was a good question, by the way. Now, here, when you take a look at these areas, you will observe that frontal formation can occur here or frontogenesis can occur in these areas. Maybe sometimes warm air moves slightly further north, or cold air can move slightly further south, also. That can also happen. Here, also, cold air can move north, or warm air can move south. But more or less, in these areas itself, you will have the frontogenesis which will occur. So, can I say that frontogenesis occurs where? In the region of mid latitudes. That is observed in mid latitudes. What is mid latitudes? In mid latitudes. Now, mid latitudes basically indicating the region that is around almost 40° to 65° north or south. That is where the frontogenesis will occur. Will you have a frontogenesis condition in India? No. India is a tropical country. Every region will get heated up quite sufficiently, isn't it? And that is why you don't have such a large area in India for hundreds or thousands of kilometers, which will be very cold. You have small pockets, Leh, Ladakh, etc., which are very cold. But that small pocket does not constitute an air mass. Okay. For a front, you need air parcels of very different property for a frontal formation. Okay. So that is the case of front formation. Now, there are different types of front based upon the behavior of the air. So you have four different types of fronts: stationary, cold, warm, and occluded. What is a stationary front? Let's suppose in a region, let's suppose in a region You have the case that the cold air has come. Okay, cold air has come, and simultaneously you have the case where the warm air has also come into that location. Okay, now none of these air masses after reaching here have enough power to enter into each other's territory. They lie stagnant there itself. Stationary means what? Stagnant. They don't have the power, right? That is a stationary front. So the animation that you saw in this case is the case of a stationary front. Neither the cold air is moving further nor the warm air is moving ahead. They are lying there itself, right? That is a static front. Okay. So basically, yes, Avanti, absolutely. Basically, stationary front means no further movement. Movement. Okay. Now, here, a couple of things can happen. Let's suppose you have cold air, warm air. Okay. You have cold air, and here you have warm air. Now they have come head to head with each other, and neither of them is able to move in each other's direction. So, two things can happen. First, let's suppose over a period of time, cold air gains more energy, starts pushing further, or warm air gains energy, starts pushing forward. In that case, the frontal development can happen. But it can also happen that none of them gain the energy at all. So, after a period of 14 days to 25 days, right, around 2.5 to 3 weeks of time, if none of them are able to move, they lie there itself. What will happen? This air will get a bit warmer and this air will get a bit cooler. So, this zone of transition, this difference which was there, that will start getting diluted. Rather than separate warm and cold air, you will have warm, cooler, cold air. No such zone of difference. So the front can die. So death of a front is what is referred to as death of a front is known as frontolysis. Okay? That is what is referred to as the end of a front. Front has ended. Front has ended means what? That zone of transition no longer exists. You don't have that immediate zone of transition. That is the case of a stationary front. These are the possible outcomes. Then you have a cold front. In this case, what will happen? Pressure difference can create a movement. But please understand one thing, Shriharshini, cold air is being supplied by which particular pressure? The polar high pressure will provide that cold air. Warm air is being provided by which pressure? By the subtropical high pressure belt, which is a dynamic pressure. Both of them are being provided from a high pressure. Ideally, they converge around 50 degree to 60 degree, creating a low pressure zone. It can also happen that both of them have equal power. If both of them have equal power, then neither the cold air will be active nor the warm air will be active. Okay, because we have seen one thing, pressure is not only determined by temperature. It is not always the case that warm temperature means low pressure. Warm temperature can also be the condition of high pressure. We saw that in yesterday's session when we talked about the condition of dynamic pressure, right? Where we saw in the closed room that how you can have the rising of air parcel, creating a condition of a low pressure, right? So, pressure is not only temperature dependent, pressure is also dependent on wind movement. So that is why it is not always going to be the case that this is low pressure. This can very well also be the condition of a high pressure. Okay. So it is not something which we can take for granted or a certainty. Okay. I hope that is clear. Now, cold front, in this case, cold air is active. Cold air is active. And cold air pushes into the region of warm air. It suddenly pushes up the warm air. We will take a look at it with the help of animation. Warm front, in this case, warm air is active. Okay. Warm air is active. So when warm air is active, it basically pushes the region of the cold air also. Here also, warm air gets uplifted because it is lighter. But let us understand this with the help of the animation. Otherwise, how are we different from the NCERT in this case? So, first we talk about the case of the warm air. Observe that you have a separate region of cold air, bluish color, and you have a separate region of warm air, reddish color. Observe here, it is the warm air which is active. I hope we are able to see. And still, warm air, as it is pushing ahead, it gets lifted above also. Why? Because warm air is lighter, less dense. It will get pushed ahead. Okay, so that is the case of a warm front. I hope everybody is able to understand this with animation. Okay, so warm air very slowly rises ahead. Right? Observe the formation of clouds also. Tomorrow, day after, we shall be covering the case of the clouds also. No, cold air is not static. Observe the portion of the cold air. Even the cold air is being pushed ahead. Are you able to observe this? Even the cold air is slightly and steadily being pushed ahead. Right? So, depends on the strength of the warm air, how strong that warm air is. Okay. So, tomorrow or day after, we will be studying about the type of clouds also. But here, if you observe, can you observe the cloud which is quite horizontal in terms of its development? You don't have a very vertical development of cloud, you have a horizontal layer of development, isn't it? I hope we are able to observe this. Now, does this particular animation that we started the session with, does this ring a bell? Does this weather phenomena make sense to you now? That how can we have these kind of conditions getting created? So what does this tell you? Near the ground surface, if someone asks you what is the temperature here, it will be cold air. But what is the temperature at higher elevation? It is the condition of warm air. And now you observe that how warm air is pushing ahead. And how is it rising? It is rising almost and moving almost horizontally, right? So I want you to observe this and then be able to understand the concept associated with a warm front. I hope this is absolutely now making sense, that why you can have these kind of climatic conditions. Can you have this condition in a country like India? No, because you don't have such cold air. You only have the pockets of warm air. Okay, so that is the case of a warm front. But then, what is a cold front? In the case of a cold front, you will observe that cold air is moving ahead. Cold air is moving rapidly, and cold air is heavy. It is sticking to the ground surface. So, what happens to the poor warm air? The warm air has no place to go, is vertically lifted upwards. Vertical cloud formation, which can be very, very large. It can be of multiple kilometers, that kind of cloud formation can happen. Okay. So that is the case of a cold front. Clear? Yash Sharma, I need some short definition. Don't worry, Yash. After these sessions are over, and this is for everyone, after these sessions are done, after these sessions are over, maybe next week, then on my Telegram group on a daily basis, I will start pushing through the notes also, and the notes for each and every session, so that you are able to revise it. And along with that, we will have the MCQs based on that also. So there you will get the definition in the notes. Right now, just try to understand what is happening. Notes, it is my responsibility. Okay, don't worry about that. Okay. Now, here, this is the case of cold front. Okay. So, what do you observe, by the way, if I talk about this region? Can I say this is a region which experience temperature inversion? Can I say so? Because at the bottom you have cold air and at the top you have warmer air. I can say so. This is what is referred to as the condition of frontal inversion that we studied last week. Do we have the case of frontal inversion in this case? No. Frontal inversion is not common in a stationary front. But frontal inversion will be common in a warm front. Frontal inversion will also occur in the case of a cold front, right? So that is how you have the case of this frontal inversion. Okay. Then you have something which is known as occluded front. Occluded. Is derived from the term occlusion. What is occlusion? Occlusion is basically the act of closing up. Something which closes. That is what is referred to as occlusion. Okay. So initially, how does the frontal development happen? I want your patience and attention here for the 2 minutes. You will understand this. Initially, you have the front, which is like this. Let's suppose cold air from this side, warm air from this side. Over a period of time, let's suppose warm air here intrudes and cold air intrudes from these regions. So this front will basically change like this. Cold air is coming from here, warm air is going like this, isn't it? Over a period of time further. Why? Because even in the warm front, you have the rise of the warm air, isn't it? Here, this is the case of the warm front. Warm front means what? Rise of warm air. Now, rise of air creates what? Low pressure or high pressure? Creates a condition of low pressure, which means what? It will attract winds from all the regions. So, you will have cold winds also coming from this region, warm winds also coming from this region. But on the ground, which wind will remain out of cold and warm? Which wind will stay on the ground? Always it will be cold air, because cold air is heavy. It sticks closer to the ground. Warm air is light. It will get uplifted. So over a period of time, you will observe that the front gets distorted before it closes down. This case is what is known as the occluded front, where the front basically closes down. Everywhere around it, you have the case of cold air itself. From this side also, from this side also. And the warm air is completely lifted up. So, with the help of the animation, you observe like this, that you have the front which is moving, it is closing down. Whatever warm air was stuck, that warm air is completely being lifted above the ground surface. Okay, that is the case of the occluded front. Why the front is closing? That is not understood. Okay, understand this. That is the distortion of the front. I will explain it once more. Don't worry. So basically, if I take this, let's suppose you consider any particular area like this, right? This is your front. Okay. Here you have warm air which is moving. Here you have cold air which is coming. Now it can create a condition of a stationary front first. It will create a stationary front. Okay. From there, frontolysis can also occur. But it can also happen that warm air can gain more energy or cold air can gain more energy. Any of those things can happen. Let's suppose here both things happen. That in certain areas, warm air is more active, in certain areas, cold air is more active. So then this front that you had been seeing, this front will get distorted. It will get like this, isn't it? This portion, I can refer to it as a cold front because cold air is active, right? This area, I can refer to it as a cold front. Again, cold air is active. What about this region? Can I refer to it as a warm front? Yes, because warm air is pushing in that area. I hope that is understood. Now, in the cold air front, in the case of a cold front, what happens to the case of the warm air? Warm air is continuously getting pushed upwards, lifted upwards. Yes. Now that means from the ground, I have rising air parcel. Rising air parcel either can be because of heating or can be because of dynamic condition. But whenever you have a rising air parcel, it always creates the condition of a low pressure. Yes or no? In the case of a warm front, here also I have the case of a rising air parcel. Rising air parcel can be due to temperature, due to dynamic condition. But whenever you have a rising air parcel, you have a condition of a low pressure. Low pressure means, remember, winds always blow from a high to a low. So low pressure is the destination of all the winds. So winds from all different directions, they will come and they will converge to the region of this low pressure, isn't it? So here in this region, I will have winds of different types which will be attracted. I can have winds from here also, which will come. I can have warm winds also, which will come. So when you have the cold winds which are coming, so can I say that the cold front will become like this? On both sides, the cold air will start dominating the ground, whereas wherever you had the warm front, it will get slightly narrower. Why? Because the cold air will stick to the ground, right? So you have the warm air here, but you have cold air from both sides which are coming in, and it will start closing it down from all sides. Why? Because remember, you have the condition of low pressure here. Low pressure will attract warm air and cold air both. But when both warm and cold air are attracted, warm air will always rise up. Cold air won't rise up to that extent because cold air is hugging the ground surface. So, on the ground surface, what am I going to observe? That cold air has completely pushed the warm air upwards. So I will have warm air which has been completely pushed upwards, and from all sides, cold air has surrounded the ground. That is what is your occlusion or the closing. So now observe this animation. Here also you have cold air. Here also you have cold air. Here also you have cold air. It is pushing from both sides, and the warm air is completely being replaced from the ground surface. Observe that you do not have any warm air on the ground surface. It has been pushed up. This is the case of occlusion. Occlusion means the front has now been closed. Now, on the ground surface, you have uniform temperature, cold conditions. Death of the front has occurred. Occluded front eventually leads to frontolysis. Leads to frontolysis. Is this clear and understood? Let me guarantee you, you will not find this detailed manner of explanation even in your reference books, and for that matter, many of the educators as well. So I hope now it is understood in as great detail as it is required. From frontogenesis to frontolysis, the case of the warm front, cold front. If you have understood this, guys, understand that even your extratropical or temperate cyclone is also understood now. You will see how quickly you are able to now understand the case of the temperate cyclones as well. So, by the way, the NCRT, what it has done is, just to give you the reference, this entire explanation that we had, NCRT has done this in this small paragraph and then in this paragraph. Okay, that is your entire NCRT. No, Harsha, rainfall is not the in the occluded front. The rainfall is because of the eventual frontolysis. But warm front causes rainfall, cold front also causes rainfall. Frontolysis is just the end, the death of the front. That's it. Okay. Now, before directly jumping into this portion that is extratropical cyclone, a brief idea. What do we understand by a cyclone? Right. Cyclone means what? Circular movement of winds at very high speed. Large scale circular movement of winds at high speed. Now, why is it caused or why is it created? So, whenever you have the condition of very intense low pressure, very intense low pressure, it will attract winds from all different areas, not just any low pressure, very intense low pressure. It will attract winds from all areas. Now, these winds, when they are coming to the low pressure, they will be influenced by the Coriolis force. For example, if I have a low pressure in the northern hemisphere, right, winds will be coming from here, 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 and here. But the winds in the northern hemisphere, they get diverted or they bend to their right, isn't it? They bend to their right. So, over a period of time, let's suppose I make one of you stand at the center of the low pressure and ask you what is the direction of the wind movement. For you, who is standing at the center, the wind will appear to move like this in a circular motion. So, that circular motion is referred to as the case of cyclone. Okay, that circular motion refers to a cyclonic circulation. So, this cyclonic circulation basically creates lot of havoc, lot of destruction. Wind movement is very, very strong, and that also ends up creating the condition of destruction, loss of life, property, flooding. Everything is associated with that. Okay. Now, there is another case, what is known as an anticyclone, just the opposite of it. Difference between cyclone, hurricane, and typhoon. Cyclone, hurricane, and typhoon, all three are the same property. that is a cyclone. They are named differently in different oceans. That is something that we will study in detail tomorrow. About the hurricane, typhoons, everything. We will study in detail tomorrow. Right, the cyclones impacting India also. Today is the generic aspect. So cyclones get created due to intense low pressure. Anticyclones get created in certain areas. You have intense high pressure. High pressure means thinking air. So if you can see this image, the first one is an anticyclone. Air is sinking. Also following the Coriolis force. Coriolis force is something that no winds can avoid unless until you are in at equator. And after this, the winds will move away from high pressure to all the regions. Why? Winds always blow from a high to a low. Okay, I will repeat this so many times, even at the time of examination, if you retain anything or not, at least winds always blow from a high to a low, should not be forgotten. And here you see the case of a cyclone, a low pressure. Winds coming from all different directions, rising up and forming clouds. So anticyclones are considered to be having dry conditions, no cloud formation. And this is supposed to be extremely disturbing weather with heavy rainfall, dense cloud, thunderstorms, lightning, everything is associated with this. Okay? So, but then when we talk about the cyclonic circulation and anticyclonic circulation, it is different in the case of the northern hemisphere. It is different in the case of the southern hemisphere. So, first of all, let us consider the case of anticyclone in the northern hemisphere. Okay. And then anticyclone in the southern hemisphere. When we consider the northern hemisphere, here, if anticyclone means intense high pressure, means winds will originate and move in all different directions. Now, when the winds originate in all and move in different directions, in northern hemisphere, they will bend to the right. Isn't it? So, if I ask you, what is the generic direction of wind movement in this particular case, it will be what? Clockwise? Can I say so? So this will be clockwise circulation. Now, anticyclone in the southern hemisphere, you have a high pressure, right? Winds will originate, but they will bend to the left. What is the general movement in this case? It is basically anti-clockwise. Anti-clockwise. Now, what about the condition of a cyclone? Cyclone will be exactly opposite of this. Cyclone is a condition of low pressure, means winds will try to come, they will bend to the right. Isn't it? So, what is the generic movement of winds here? Inward moving wind like this. This is anti-clockwise. Anti-clockwise. What is the generic movement of winds in this region of, let's suppose, low pressure when we talk about cyclone in southern hemisphere? They will bend to the left. So that is clockwise, right? This is how logical it is. I have seen multiple candidates rectify this clockwise, anti clockwise, and they commit mistakes. Please do not do that. Whenever you have a prelims type question that what is the cyclonic circulation in the northern or the southern hemisphere, take some time and then draw it in a piece of paper, arrive at a conclusion. You will never commit mistake in the left and the right bending. But if you try to rectify clockwise and anti-clockwise, you will get confused. So please apply the rare commodity that you have. That is your logic. Use it sometimes. Okay. But in case you want to rectify it, this is the table where you can see that cyclonic circulation in the northern hemisphere anti-clockwise, in the southern hemisphere it is clockwise, anticyclone, clockwise, and anti-clockwise. Okay. Now, then we come to the types of cyclone. There are different types of cyclone. For example, in India, we are impacted by a cyclone which originates only over the water bodies and hits us with a tremendous force. Whereas, when we talk about, let's suppose, regions like, observe this map. This is a satellite map of today, right? Today afternoon. Observe this cyclonic circulation, which is happening in the region of Northern Europe. Okay. This is what is referred to as a kind of a temperate cyclone. So, cyclones, based upon where they exist and where they occur, they are classified into temperate and tropical. Temperate and tropical. India is always impacted by the tropical cyclone. Okay. In fact, even the formation is different. Temperate cyclone will always be created or formed. Formation occurs because of frontogenesis. Now, in frontogenesis, guys, the low pressure which will be created, after all, cyclone is always going to be associated with low pressure. High pressure is anticyclone. Now, frontogenesis, the low pressure created in frontogenesis, is it a thermal low pressure or is it a dynamic low pressure? It is always going to be a dynamic low pressure, isn't it? So, this is the case where the formation is associated with the movement of the winds. Dynamic low pressure. Yes. Whereas in the case of tropical, the formation, the low pressure formation is thermal low pressure. Okay. Now, fronts can be created over huge distance. I've shown you the map also. Fronts can be created for hundreds and thousands of kilometers. So these cyclones are very large. Whereas these cyclones, tropical cyclones, are much smaller. Large as in the diameter can be 750 to 1000 kilometers. This will be around 250 kilometers, the entire diameter of the cyclone. Okay. Now, region where the temperate cyclone will be created. What will be the region? Can I say mid latitudes? That is where frontogenesis will occur. And what about this region? This case, tropical cyclone region. Tropics, Tropic of Cancer to Tropic of Capricorn, Tropic of Capricorn, isn't it? That is the entire region where you will have this formation. Now, in these mid latitudes, by the way, which is the permanent wind system which is present? Which is the permanent wind system? Tropical, for example, are marine, maritime, humidity high, yes. Not generally high pressure, sub 30 degrees high pressure, otherwise low pressure. In this region, you will have the presence of westerlies. So cyclones will move from west to east under the influence of westerlies. In general, what is the wind movement in this area? West to east, isn't it? Now, in this region, tropical cyclones, the wind movement is permanent wind system is trade winds. Now, what is the direction of the trade winds? East to west. So, direction of movement is cyclones move east to west. So, you see, just from your basic information of pressure and temperature, you are able to deduce this much detail. Today, we are just going to talk about the case of a temperate cyclone. Tropical cyclone in detail, the naming of the tropical cyclone, the agencies involved, everything we will cover tomorrow. But today, when you talk about the case of the temperate cyclones, how do they get created? So, once you have understood the frontal formation, guys, now this is a cakewalk for you, right? It is the imagination of the frontal formation that is difficult. Once that is understood, this is a cakewalk. So, here, first of all, why will temperate cyclone get created? Why will this intense low pressure get created? This intense low pressure is never going to be created because of intense heating. You will not have very intense heating of the northern Europe, right? You will never have the intense heating of the region of northern Atlantic. Having said that, Europe is experiencing extreme heating due to which you have the wildfires. We will have a video for the wildfires in Europe, the entire reason of it, tomorrow. All of you who have covered the sessions till now, now you will be able to understand the exact reasoning of the impact of maritime, impact of continental air masses, adiabatic heating, etc. So watch out for this page tomorrow. Tomorrow you will have this video about the why you have the region of France, Bordeaux region in France, Madrid, the area around Sevilla in Spain, which will have the case of wildfires, why they are experiencing so, right? So all of that will be covered tomorrow. Don't worry. Now, here, this intense low pressure will be created. Why? This intense low pressure will be created because the cold air coming from here, warm air coming from here, will form a front. That front will always mean rising air parcel. Rising air parcel means on the ground surface, low pressure, more air will come, the cycle continues. But how does it start? Let us understand it through various different stages, right? Stage one, cold air and warm air come in front of each other, head to head. This is the stationary front. Now, this stationary front, once it is created, it can have two outcomes, what we have talked about. Either frontolysis can occur after 14 to 25 days, if none of them move in each other's direction, homogenization or uniform formation will occur. The front will die there itself. Okay, front will die there itself. So that is where you will have homogenization, or further frontal development can occur. Deepening of the front can occur. If the deepening of the front occurs, development, further frontogenesis occurs, then you enter the case of a stage 2. Stage 2 is where you observe warm front is getting created and cold air is also trying to move into the region of the warm air. So this is where it will lead to simultaneous development of a warm front in this region and cold fronts in this area. This is when a cyclonic formation can start. In this, warm air pushes into the region of cold air region, and vice versa. Clear? Now, once this happens, then you have the development of the mature stage. In the mature stage, what has happened is that you have simultaneous formations of two cold fronts and you have the formation of a warm front. Okay, you have the formation of a warm front and you have the formation of two simultaneous cold front. Okay, now, by the way, I have shown you the image of warm front and cold front, and animations of warm front and cold front also I have shown you. Where do you think that the front is more steep out of the warm and the cold front? Where do you think the front is more steep? It is always going to be the case of a cold front. Cold front will have a very steep gradient. Warm front will have a gentle gradient. So means what? The type of cloud formed here is different from the type of clouds getting created here and here, right? Weather conditions are different. Now, coming to this particular region, understand this and pay attention here carefully. Be it the cold front, if you consider the cold front, cold air is pushing forward. When the cold air pushes forward, the warm air is pushed up. Cold air is pushing forward, warm air is pushed up. Here, the warm air is pushing forward and the warm air is rising up. So, here, what you have is the case of rising air. Rising air will always create a low pressure on ground. Now, low pressure attracts winds from all direction, more winds from colder area also, from warmer region also. These winds continue to converge, continue to converge. When they continue to converge, it will lead to what? More of rising air. And that is the process which will continue. A cycle is going to continue. This is going to lead to intensification of the low pressure. Intensification of low pressure will happen. And this is where you have the case of cyclonic formation. More winds will come, more winds will rise. It will be a circular motion which you observe in this case. Are you observing this? Winds are coming from here also. Winds are also coming from here. I hope you are able to observe these different winds. One wind, if you observe the trail, it is coming from here. But another wind, if you observe the trail, is coming from here. Warm air is also coming, cold air is also coming. And that is where they are rising up. Further low pressure is getting created. So, this is the very and the most important part in your entire understanding of a temperate cyclone, the intensification of the low pressure. Why does the low pressure get or create more intensification? How and why does it get intensified? This is the reason. It is here that you have very heavy rainfall, strong wind movement, and eventually observe what has happened. This is where on the ground surface, occlusion has started. Because of so much of rise, you have the warm front and the cold front begin to close down, right? Warm front and the cold front, they begin to close down. And this is where the region of the low pressure, observe on the ground surface, only cold air remains. Occlusion has happened, eventually leading to dissipation. That is when the cyclone ends. So, this is your entire cycle for the development of a temperate cyclone. Eventually, frontal will lead to the dissipation of the cyclone. Okay, so because this gets created across the entire region of a front, that is why this is also referred to as the case of frontal cyclone. It gets created beyond the tropics in the temperate areas, hence known as extra tropical cyclone. Now, front formation happens across almost a wave like format, the entire front formation, hence also known as wave cyclones. All of these are the names of the same phenomena, that is temperate cyclones. Cover this much, nothing more is required, even from the point of view of your mains examination. And nowhere else will you find it provided in such a detailed manner, is my guarantee. So that is why these sessions become so very important for you. This is basically where you will get the detailed understanding of the concept more than even your, for example, if you read GC Leong, if you read Savinder Singh, even if you read, let's suppose, any of the books out there, this is the most detailed information that you will get. Okay. Only this coverage is important. And out of this particular cycle, if you are able to produce it in the exam, I guarantee you will get more marks. They bring Western disturbances. That is a frontal depression, not always a cyclone, right? But a frontal low pressure which gets created, Sudhanshu, in the region of Mediterranean, which is then carried forward by two combining weather movement. One is the case of your westerlies, other is the case of your subtropical westerly jet stream. Both of them are responsible for that. These can be created, Avantika, both on land as well as the sea. Yeah, because frontal formation can be created anywhere. So that is why these can exist anywhere. Okay. So revise this, form your short notes, and tomorrow we discuss the very important case of tropical cyclone, its formation, its naming, its genesis, its dissipation, its strengthening, everything we are going to discuss tomorrow. Thank you for being patient enough for today. And I hope that patience has paid off in terms of understanding this detailed concept of geography. The purpose behind it is very simple: ensuring that geography is not a subject of rectification, ensuring that geography is a subject where understanding and conceptual clarity is paid attention to. If you have liked the video, don't forget to click on the like button, share it with your friends, subscribe to the channel. Tomorrow we meet again, and tomorrow we discuss the case of the tropical cyclone. Take care. Goodbye. Thank you.